video, we are going to see an experiment called flow through Orifice meter, circular Orifice meter. This part is considered as a Orifice meter. Here we having a small opening through which the pressure flow, and by help of this pressure the water will circulate from the sump tank to the collecting tank. First, we have the apparatus required for this experiment is U-tube manometer and Orifice meter, collecting tank, sump tank, and a motor. And this is the inlet valve, and here this valve is called as outlet valve. Okay. First, we have to level the manometer head levels. Here they show two levels, which is called as H1 head 1 and H2 as a head 2. We have to level this two heads in a same level. For this we are going to use this walls to open the wall simultaneously to release the pressure, which will help us to level this mercury shown in the U-tube manometer. Afterwards, we have to start the equipment. Afterwards, we can conduct the experiment. For this, the inlet valve will already open condition. We only have to open the outlet valve. After we open the outlet valve, the water flow will get starts from suction tank to the collecting tank. Here the collecting tank area will be as note down as 40 into 40 centimeter, 40 by 40 centimeter. Okay. Then first we have to calculate after opening this valve, we can see the fluctuation in your U-tube manometer. Head 1 will rise to up to 20 plus, and head 2 will be rise up to 10, 5 to 10. This will be the range of this U-tube manometer head range. And after that we have to close this valve, which we can stop the water flow through the sucking tank again. After that we have to calculate time taken for water rise in this tube. You can see this tube here, which is considered as a pressure rising through the flow. Okay. We have to take time using a stopwatch up to 10 centimeter. Like this, we have to take at least 4 values for each flow. After taking this value, we can go for a calculation part. For the calculation part of the Orifice meter experiment, as we seen, we can note down the diameter of the inlet pump, Orifice diameter, which will be in the equipment setup, and length of the collective tank and breadth of the collective tank, which is again 40 into 40 centimeter. From this we are going to take we can take the H1 value and H2 value. From H1 value and H2 value we can calculate the difference of the head value, and time taken we have to take from the equipment. After that we are going to calculate the actual rate of the flow and theoretical rate of the flow. For that we have formula as for the actual discharge. The formula is Q actual is equal to area into R divided by T. Area indicates the area of the collective tank in meter square. We have to the values will be in centimeter. We have to convert the value to meter, and then the R is the value of height of the collected water in the tank, which will be 10 centimeter. As we taken a time for rise of water for the 10 centimeter, we are going to take it as a 10 centimeter, and T indicates the time taken for the rise of 10 centimeter. From this we can calculate the actual discharge of the Orifice meter experiment. And then the theoretical discharge. For theoretical discharge, the formula is K into root of small h, where K can be calculated as A1 into A2 into root of 2G divided by A1 square minus A2 square. A1 is the area of inlet pipe in meter square. To calculate this area, we are having the diameter value of the pipe, which is also indicated in the which is also indicated in your experiment setup itself. And the value of this inlet of the pipe is 0.025 meter, which is also in centimeter in your equipment. We have to convert it in a meter, and then which will be in millimeter. We have to convert it in a meter value. And for the again next A2 is area of the throat. As I said before, here it is a small hole which is considered as a throat in Orifice meter, but it will get differ in your Venturi meter. So for Orifice meter, that area can for calculating that area, we can also have the, so we are already have the diameter of the small hole. That the hole's diameter is 0.015 meter, which will be written as 15 mm in your apparatus setup. Again, G is your specific gravity, which is marked as 9.81 meter per second square. From this we can calculate the K value. Again for H, we have to use the formula H is equal to H minus H1 minus H2, which is the head difference in the U2 manometer, and into Sm divided by S 2 to 1 of your water column. H1 and H2 is values in your manometer, and Sm is indicated as specific gravity of mercury, which is filled in your U2 manometer, and Sw will be the specific gravity of the water which is discharged in the collecting tank. After calculating these two values, theoretical discharge and actual discharge, we have to calculate the coefficient of discharge, which can be calculated using the formula called CD is equal to Q actual divided by Q theoretical. Here it there is no unit for it, because the both discharge is considered, we are considering both discharge will be cancelled from each other. From this we can calculate the coefficient discharge of the Orifice meter. Thank you.